Hello, this is Darren Pulsipher, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology.
On today's episode, Operationalizing Your AI Projects with Gretchen Stewart.
Gretchen, welcome to the show.
Thank you so much. I'm delighted to be here. It's been a while since you and I have talked.
It has. This is your second or third time? Third time on the show.
Third, yeah, I think it is the third.
We need to have you on more often. Gretchen is our Chief Solution or Chief Data Scientist of Public Sector at Intel, and Gretchen and myself and Anna Scott, which we've all talked to on the podcast together. We make the triumvirate of the CTO office in public sector, and we have a lot of fun. And I invited Gretchen to come on today to talk about her specialty, which is data science and specifically AI.
Yeah, I'm so delighted to be here. This kind of, I should say, started from the fact that I'd done an article that we got into Fed News on ML ops. And you and I were talking and thought, hey, it's probably a good idea to come back and talk with folks not only a bit about what's going on in the world of ML ops, but how that fits into overall data science and artificial intelligence.
Absolutely. But before we get there, Gretchen, everyone wants to know a little bit about you. So let's get your background going.
Sure.
So where'd you come from? Why are you here? And so forth.
I appreciate it. It's kind of fun to advertise, but I think I'm a great example of somebody who continually learns and adapts. I honestly, undergrad is mathematics, so I'm enough of a geek and a nerd, and been working in the technology space for over 20 years, and almost 15 of that in the federal space. So cut my teeth and honestly really felt like I found my place where we really make a difference in citizens' lives. We really help the academic researchers. The work that we do, to me, is really critically important. And I don't feel like I'm making some fat cat in some industry just making more money. So I really like that I'm in the public sector. But I
totally agree with you there. I love public sector.
I do too. It's the right place to be. You feel like it's a job where you make a difference. It's not easy. Part of the reason why I'm delighted to be working in the public sector and the federal government is who has the most amount of data on the planet? That would be our government, and so, it's the right place for somebody who is awash in data and just wants to continue to learn more. I do also have a master's in business, and then I went back to Harvard and focused on data science 3 years ago, and then became the chief data scientist. So I will tell you that absolutely can, load up a Jupyter notebook and do some of the programming in Python and PyTorch and things like that. But the truth is I don't do a lot of that these days. It really is conversations with CIOs and CTOs and what's your data strategy, and do you have all the data that you need? And oh, by the way, you probably need some data from other organizations. So how do you create that governance model, et cetera? So those tend to be a lot of the conversations that I have. So not putting fingers to keyboard, so to speak, anymore. So I feel quite rusty. So if you ask me a Python coding pragma specific question, I might.
I won't put you through that. I promise. Even though it would be kind of fun.
It would be fun
because you know me. Even though I'm not supposed to be coding, I still code because it is in my blood. I am a software engineer, and I'm going to code the day I die. I already know it.
Yeah. Well, and I started, in software engineering too. So I totally know what you mean. And it's like having another language that you know.
Yeah, absolutely. So Gretchen, let's talk about our subject today, which is really AI and ML ops. And what in the world is that, right? Is it the same as DevOps? Is it the same as data ops? I mean, there's a whole bunch of, everyone's throwing ops on the end of things. So let's start first off with AI and ML. What's the difference? Make this simple for us because those words are thrown around like crazy.
Absolutely. So when you think of artificial intelligence, think of it as the big circle, so to speak, and think of machine learning as techniques that are part of artificial intelligence. So it's not different, it's really a subset of artificial intelligence. These are algorithms that derive their strength from an ability to learn from available data. And so primarily you're learning either from supervised or unsupervised data. There's lots of nuances, but yet that's the best way to really think about it. So machine learning
All
again,
right, so ML in machine learning, sorry,
yes,
machine learning is just a subset of AIs because there's other types of algorithms in AI that do different things.
absolutely, absolutely.
Gotcha,
Yep,
gotcha.
yep. And the real simple difference between supervised and unsupervised learning is the data labeled. It's that simple. So if you have supervised learning, that means the data sets are labeled. That means it is already mapped out as to what that data looks like, what's the data size, and it just makes it much easier to classify and predict. Where unsupervised, what you're really doing is trying to find patterns in the data. So you're really almost looking at it as how do I associate things or how do I cluster them in a way that might make them interesting.
Okay, so I'm going to restate what you said so I make sure I understand because that's how I learn. Supervised could mean someone sitting there labeling things.
Hmm.
That is a dog. That is a cat.
Exactly.
That is a hot dog, right? We all know a Silicon Valley reference to
Yes. It's an
hot
apple.
dog, not a
It's
hot
an
dog.
orange. Exactly. Yeah.
Exactly.
Yep.
Unsupervised means that the machine is learning to create relationships between data based off of finding common patterns throughout the data.
Exactly. Similarities or potentially differences. But it's
Or differences.
the yeah,
Okay, okay.
yeah, you could think of it in ways like you're clustering information together. So it's unlabeled and you're clustering similar things, or maybe you're clustering things that aren't similar. So you might think of it for market segmentation. That might be a way where somebody starts to look at markets or different markets. And then also unsupervised could be relationships between, I'll call it different batches of information or different data sets. So, as an example, a customer who bought this item might also buy that item. So that association could be another way to think of unsupervised learning. So, you know,
Gosh,
Netflix,
I mean, both seem very powerful to
example
me.
of unsupervised learning. Some of the information is labeled, but some of it is really just based on comments and information that you've input into your Netflix, where it can say, "Hey, if you bought this or you like this particular movie, you might like this one."
Yeah, I kind of hate those Netflix suggestions, especially after my granddaughters have been visiting and they're watching, Teletubbies or whatever. All of a sudden, I don't really need to watch a Teletubby movie. I don't.
I
It
totally
just
get it.
doesn't.
I totally get it. Then there's specific math techniques, basically. If you're clustering something together, there are k-means or KNN, nearest neighbor clustering algorithms. And we could get into all of those, but that's really from a simplistic level. That's really what we're trying
Well,
to do.
that's where we want to start
Yeah,
first. Is
yeah.
simply because we could spend days and days going over all the different AI stuff, but today I want to focus a little bit on the ops side. As we kind of mentioned, people just throw ops on the end of everything now, which really means operations. But I think it should be more like automations. Maybe it shouldn't be op; it should be ot.
Yeah,
And maybe
I think that makes sense. And to your point, I think that you'll see people say DL ops, DL meaning deep learning. So that's even a smaller subset of machine learning, and that's where you have really serious graph algorithms and neural nets and things like that. You hear people talk about, and they've started to put ops on the end of that. So The first thing,
So what does that mean?
yeah,
What does that mean when they say put ops on the end of that?
yeah. Well, the first thing is it's not as sophisticated as DevOps. So think of it as being influenced by the widely adopted idea about DevOps approach to creating and customizing applications. But what folks are really trying to do is create I'll call it a set of practices to help optimize the reliability and the efficiency of machine learning designs, development, and execution. So almost more of like a marketplace where you've got the ability to create and operate custom applications, but then you have those to be able to share with others. Because again, many of the models and the algorithms that are being used lots of times are already optimized and are in what people today think of as model zoos. So 10 or 15 or 20 already optimized models that could be all for machine learning. So the idea is that you can have these methodologies and technologies to help you streamline your machine learning models. And the best way to do that, honestly, is with a whole bunch of tools that are either open source or specific software vendors have created, again, to make that creating, developing, designing, executing flow much easier.
So this sounds a lot like where software development was maybe 30 years ago when they first started creating libraries, right? Oh, I'm going to create this library so everyone doesn't have to write a string class in C++. I just use the standard library. Are there standard ML models out there that I can use over and over again? Or is there a marketplace that's starting to build around this? What's that look like?
That's a really great question. And what I've seen in terms of the I'll call it supervised learning, you think about classification. So these are vector machine decision trees, random forest, linear classifications. So a lot of those are math equations that have been around for quite some time. Another technique that's used in supervised learning is regression. So you think about linear regression or log regression or polynomial regression. Again, these are math equations that have been around a while. So many of those specific algorithms are already done and optimized and are available in tools such as Converge.io, or C3 AI has a really nice ML design flow. Databricks, SAS. So there's a bunch of vendors that have many of those algorithms that are already optimized sitting there for you to be able to to use it. And then what you're really able to leveraging that software is do that whole workflow. So think of a quick, agile, hey, I've got several data sets. I would like to link these together, multiple variables. Here's the technology. Now let me see when I point it to 2 or 3 data sets that I have, what the results are. And,
gotcha. So,
and those
are
fabulous. So you don't have
to,
go through all of that. Converge.io, honestly, which Intel owns, it has a really nice graphical user interface where literally you are just mapping out, with boxes, triangles, almost think of it as a Visio kind of a diagram, just quickly lay it out and literally hit the go button.
So this is helping me build up my AI pipelines,
Exactly.
Right? By you're saying by weaving together ML algorithms and or models on my data streams as they're coming in.
And then there are also really great open source tools. So these are ones that the community's been developing that people add to that you can easily go to GitHub and download, like Kubeflow with a K, Kube flow, or Metaflow, or Kedro, or MLflow. And again, these are great tools that really help you with that DevOps. And the cool thing, for somebody like an Intel, where we want to make sure that they leverage the best libraries that we have, math kernel libraries and OpenDAL or CNN libraries, et cetera, that we've already optimized. The good news is that's already built in. So somebody doesn't have to go and, pull down specific, I'll call it, not only the libraries and do any recompiles, all that stuff is already done and built into some of these really nice open source flow tools.
And we've talked about this on the show before. A lot of AI and ML projects end up being science experiments where I do it once, I get great information out, and then the data scientist has moved on to something else, and it's like, but you didn't operationalize it, right? So is this where ML ops is moving to? Is because what you were talking about is primarily training or learning, but what do I do after after my model's learned? I got to deploy it, right, and actually provide real value.
Yeah. And some companies specifically are leveraging those tools. Domino Labs is another one that does ML ops, where it really almost creates that marketplace. So you've got a customer. So in our public sector, you have a customer who's working on the nuclear subs, and they're doing some object detection or some clustering classification. Well, that work could be applicable in the Air Force or might work somewhere else. And to your point, where people have done this work, then they finish the visualization, provide the results, and move on. So the idea here is that would really catalog it. And even some of the, defense industrial base that we work with are adding and almost creating their own sets of catalogs internally at their own companies, so that they can really help operationalize that and really build agile environments so that somebody could just, okay, this is a multivariant problem. Maybe I want a couple different algorithms that I might want to leverage. And I'm going to then weight them in a different way depending on the results or the accuracy. And I might test that out a couple times, and then all of that information would be captured. And then somebody could go back and go, oh, Joe did this great work. He weighted it 60-40, and look at the kind of results that he got. But this is the data sets that he was using. Well, our data sets are different based on what we know in those characteristics. So maybe we'll take what he's done, but we might tweak it a little. But at least there's
okay. So yeah, this brings up a big concern I have, actually, but it's the same concern we have with open source software, with these open source models and things. How do I know that I can trust that model, that someone hasn't trained that model? Maybe I'm doing facial recognition, and I'm now going to use that model to do my facial recognition to allow people into my secure lab. How do I know they haven't trained it to ignore their own face?
Yeah, and the truth is,
I mean, how is there any way to know?
Yeah, the truth is, right now, that's part of I'll call it the trustworthiness and the ethical nature of what we need to do, where there is now an expectation that people now document those kinds of things, i.e., where did you get that data set? Is it a publicly available data set? Is it a synthetic data set? Is it something that you maybe created on your own, and how did you do that? And so you have to, as we move forward, people need to describe that. I mean, so this gets into, honestly, something that's so fascinating and interesting to me. It's really the trustworthiness, the ethicalness, the how can you be more responsible about what you're developing to ensure that those models have gone through a set of rigor in terms of questions, and to your point, where does that data come from? A great example that of AI gone awry is Tay. The system within 30 hours that started to become even more racist than you could imagine gets pulled. All that great work that Joy and team are doing at MIT Media Labs around facial recognition, and you understand how that could have happened. And I honestly don't think it's malicious, but folks basically took data sets of parliament, and data sets of people that were in Congress, and data sets of people that are in, leaders of companies, CIOs. And oh, by the way, they kind of look like you, and they aren't really representative of the globe. And again, I don't think people maliciously said, I'm going to train this model on a on something that doesn't look like the globe, that doesn't have
a non-diversified
right,
set, right?
good diverse representation. I'm just going to pull these data sets.
It's interesting because China had the same issue and China has done incredible work in AI, but they had the same issue with facial recognition because most of their pictures were of Chinese people.
Right.
And when it came to Caucasians or African Americans, it could not figure it out because their data set was so homogeneous, AKA TikTok. Yeah. And maybe people don't know this. TikTok is a Chinese company, which means it's owned by the Chinese government. And TikTok provides more AI data sets to China than any other place. So when you're out there doing your TikTok dance, China's AI algorithms are getting smarter. Yes. So just, be wary of that.
It's very true. Well, and honestly, China is one of those places that really has factories of people who are labeling the data, so, wow. they have, and granted, they are absolutely using, unsupervised data, but a lot more of their data is in those data sets. So then that also makes it more accurate, because if it's unsupervised, think about it, you're trying to cluster and find patterns as opposed to you've already labeled the data, and therefore you are really doing much more sophisticated machine learning against applying algorithms against that. So you're doing and it's not better or worse, it's just different work, if you know what I mean. And that's honestly one of the things that Intel's been working on with some of our university folks at MIT and Berkeley and others, in terms of leveraging artificial intelligence to help label data. That's
interesting. So the supervisor is an AI that's doing the supervision.
Right.
Uh-oh, Gretchen, you're starting to scare me a little bit. Who's watching the AI? Oh, an AI is watching the AI.
Yes. When you think about ML ops, for a long time, it really was that single person who was doing the work and then produce the results. And the idea now is that, okay, it needs to be a team of people, and you need to have a diverse team of people. You need to have people who come at this maybe not from the I'm a PhD researcher, but hey, I'm a practitioner, or I'm a user, or I'm somebody who ethnically has a whole different background and a different worldview than you do, and I need to be part of that. And
gotcha. So in that case, the ML ops helps with the fusion of and coordination of those workers, data workers. I guess that's what we would call them, right?
Mm-hmm.
That are doing supervised learning with the algorithms. That really makes a lot of sense to me.
Yeah, and again, it's one of those things where, and you know this, it's like being a cloud practitioner. You know that 10 or 12 years ago, the answer was cloud. What's the question? And so now it's AI. What's the question? You know what I mean? And yet, as I like to remind people, the first conference to talk about artificial intelligence and machine learning was in 1956. It was at Dartmouth College. It was, funded by the precursor to the National Science Foundation. But bottom line is, many of these are math equations that have been around for quite some time. And granted, there are then brilliant additional frameworks like a TensorFlow and others where you then can build from those. But the truth is, there's still a lot of the basics in terms of log regression, linear regression, clustering algorithms, et cetera. These are ones, again, that have been around a long time. But now, as you know, You've got the compute, you've got the storage, you've got 5G, you've got the capability to do what we're talking about literally as your car is, passing the traffic light, where you're able to, that person's, there was a silver alert. There's someone missing. We know that their license plate is them. And that you're you've done the training, and now all of a sudden you've got that data and that information literally next to the technology, as opposed to having to bring all of it to the technology. We've brought the technology to the data. So it just opens up some really, really fun and interesting problems that we can solve. But to your point, then it brings up a lot more of those conversations of, okay, how do we train this? What was the original data that we used? And by the way, you get, as you hear people talk about it, model drift. So after a certain point in time, you can start to see that you need to basically retrain, and that maybe you need to have the algorithms or bring in a different one or weight those differently to be able to then get more accurate information, because, hey, there's even more data, and more data that's more diverse, which is all good, increases your level of accuracy. But
so if I have my pipeline, though, in my ML ops, then I can do this continuously.
Exactly.
Just like, so the movement, is what I'm hearing, is very much like what we went to with software development, where I have continuous integration and deployment.
Mm-hmm.
I'm going to start seeing the same things in ML and AI, right?
Yes.
Or AI and ML, where the models will be updated often as they become more and more accurate, and then I can combat that model drift that I see there. And I think I even have a podcast. I do have a podcast about ML security attacks, because there are some physical attacks that you can play on ML that are doing vision, that I would like to know, that's a vulnerability, update the model so it can now detect those attacks. So I love where you went with this, Gretchen. I can't wait to hear more. We need to have you come back and go a deep dive on the different data analytics and AI techniques, and we'll schedule that one up so that we can say, hey, machine learning is good for this, linear regressions are good for this, genetic algorithms are good for this. Wow. Yep. That's another podcast we have in the future. How's that sound?
I think that sounds awesome, because the truth is, in some cases, that's really easy and straightforward, and in other cases, that's part of the science, and that's part of the art.
Well, wait. You were mentioning earlier, though, that maybe AI algorithms could choose which AI algorithm to use. So did you just get rid of your own job?
I don't know, maybe, but I think you might solve it, but in the end, you still need somebody to help with the interpretation,
No, I totally agree.
There's this great book, honestly, and I'm not going to remember who wrote it, but Harvard, it's out of Harvard Business Review, and it's called Human in the Middle, and it really, Human plus Machine, and it really talks about the fact that there are ethics jobs, as we were talking about, or responsible jobs. Those didn't exist 2 or 3 years ago, and now people are starting to realize that you do need somebody who thinks about the ethics, and maybe you need somebody who is like our senior fellow Genevieve, who's an anthropologist. So you need people with different backgrounds, and as this gets more and more inculcated into everything that we do, then you really do need that diversity, and you really do need people with a lot of different thoughts, and it is not a single person solving this problem.
I think that's great. Gretchen, thanks again for coming on the show.
You're welcome. It was great fun.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and do something wonderful.